They're stuffed inside. That's the stuffing. All right. So we're going to take the turkey out of the bag, and we want to figure out what the upward force exerted by the bag is if the bag is accelerated at 3 meters per second squared. Yep, accelerated. So that acceleration indicates what about it, Kyle? Kyle, what does the acceleration indicate?
It's moving up.
Yeah, that there is a net force upward.
Yes.
Okay. So we're going to take the turkey out of the bag. So now, if you remember from previous problems, the turkey had what type of mass?
It has
5. The potatoes were how massive? 3. And the green beans had what mass?
1.5.
Okay. So now they're taking this, and we're taking the turkey out. So in this part of the problem, the turkey no longer exists in the bag. So how much mass is in the bag now?
Yeah, why'd the bag get smaller?
Because I just drew it quick. Okay. Why you guys gotta be so critical?
looks like bar.
Okay. So the mass of the bag is 4.5 kilograms. Does that make sense?
Yeah.
Okay. Now, what forces are exerted on the bag?
Will you pick it up?
Muscles.
Okay.
Gravity.
We have gravity down and, or no, I guess I shouldn't worry about the bag. What forces are exerting on the things inside the bag, the stuffing, if you will? Okay. Gravity and the bag, right? The bag applies a force upward. Now, in this problem, they say the acceleration is 3 meters per second, right? Which way? Up. So the acceleration is 3 meters per second upward. Which force has to be greater? The bag. Okay. The force of the bag has to be greater than the force of gravity because the force of the bag is winning. It's accelerating in that direction. Okay, does that make sense, guys?
Yeah.
Okay. So we want to figure out the force of the bag that causes this acceleration. So where should I start, Rex?
What?
Where should I start?
Up there on the board.
Yeah.
Listing.
Paying attention might be an appropriate place for you to start. Okay.
I was right
So what law is that? This is example 10C, single line.
Third. Second.
Remember the scenario was, after noticing how much weight the bag was going to have, the physics teacher took the turkey out. Okay? And now the bag is accelerating at 3 meters per second up. Okay. So, what law is this? Newton's second law. Okay. Now, in the previous problems, when we've had zero acceleration, we may have skipped the step and just wrote force of bag equals force of gravity. So a lot of you guys did in your homework problem, wasn't it?
Yes.
Okay. We may have skipped that step and just jumped right to here. Or we jumped right to the force of the bag equals mass times acceleration and tried to solve it that way. Right? But you cannot skip Newton's second law. F net equals ma. F net means all the forces. Right? So what forces are acting on the object?
Gravity.
Gravity down and acceleration's up. That's net force is up, but the bag is up. The bag force is upward, right? Which way is positive going to be? Up.
Wow.
Okay. So F net then is the force of the bag minus the force of gravity, and that equals mass times acceleration. Does that make sense? Okay. The contents of the bag have a mass of what? 4.5.
kg.
Their acceleration is what? 3. Positive or negative? Positive. Okay. Force of the bag we don't know.
That was on fine.
That's what we're trying to find.
We don't know it probably.
Force of gravity is mass times acceleration due to gravity, right?
Yeah.
4.5 times
9.8.
9.8. Okay. Does that make sense?
Yeah.
Okay. And then 9.8 is not negative. Okay. Because we already took care of it right here.
Yeah.
Okay. So 4.5 times 9.8, what's that equal? 44.1. 4.5 times 3. So now I solve for the force of the bag by doing what? Adding 44.1 to both sides. So what's the force of the bag? Is that bigger than gravity?
Oh.
Well, you're measuring in nanometers. Nothing will be bigger. Okay. All right, does that make sense?
Good one.
Any questions?
Yeah.
Okay. What's the question?
Why do you have 3 on acceleration?
Because the problem they say the bag is accelerating upward at 3 meters per second squared. So we have been doing problems where acceleration's been 0, right?
Yeah.
Okay. So then we could jump to these two being equal. But in this case, acceleration is not 0, so we know these are not equal.
Okay, yeah.
Okay. All right, guys. Any other questions? Yeah. Ah, how'd you do that? Thank you for telling me that. Yeah.
How many times are 2 million?
Don't worry about it. Hey, that's a link. Guys! Imani, Jose, Whitney, Caleb. Okay. Guys, can you please act like you're at least you're juniors? Okay. Number 2. Guys, number 2 says, what is the largest acceleration the bag containing potatoes and green beans can experience without breaking? Okay. So what's the largest acceleration this bag can experience without breaking? Now, what was the maximum force the bag could exert? Does anyone remember? 8. The force could exert a maximum force of 80 newtons, right? So what changes now? Is it the same setup?
Yes, but the acceleration.
The acceleration is going to change. That's what we're trying to find now, right? In this problem, they told us the acceleration. In this next one, we're trying to find it. So in double I, we don't know what the acceleration is. Okay? But in this one, we didn't know the bag force, did we?
No.
In double I, do we know the bag force?
Yeah.
Yep.
Yeah, what's it going to be?
56.
Nope.
57.
It's going to be 80. Because I want to find the maximum acceleration before it breaks. So the maximum the bag can exert is 80. So 80 is the bag force. Okay. Now the setup is still exactly the same, isn't it? Now which one's going to be bigger, the force of the bag or the force of gravity? Force of the bag is bigger, right? So which way is the bag going to be accelerating? Up. Okay. So same thing. F net equals MA. But now I'm looking for that A. Okay. Katrina, you with me? Okay, so the force of the bag minus the force of gravity. Basically the same thing we just did, right?
What?
Equals 4.5A. Force of the bag is 80. Force of the gravity is 4.5 times 9.8, which we already know is 44.1. So we have 80 minus 44.1 equals 4.5A. Okay. Does that make sense, guys? Reg, you got a question? No? George, you got a question?
No.
Okay. What's 80 minus 44.1?
5.9.
So we have 35.9 equals 4.5A. Put it down.
Divided by
Right.
4.5. 79. I mean 7.
7.9.
7.
7? 8?
7 point. Yeah, can we just put 8?
7.98.
7.98. Approximately 8.
Yeah, just put 8.
No, just put 7.98.
Okay, now which direction is this going?
Which
Which direction is this going?
Oh.
Up. How do you know it's up, Rex?
Because it's positive.
Because it's positive. We called up positive in the problem. Right down here we called up positive, right? So we know that acceleration is upward because our answer is positive. If the answer is negative, that means our acceleration would be down. But then our bag force would be less than gravity. Does that make sense, guys? Make sense? All right, I want you guys to try